Oh, hey, what's up? All right. Hey, guys. Welcome to lesson 6, graphing complex numbers. So this goes along with your Delta Math problem number 6. So we are slowly moving into complex numbers. So there are two sections in this complex numbers Delta Math. One is called plotting complex numbers, and two is finding the modulus of a complex number. So complex numbers are very interesting, actually. So imaginary numbers are part of complex numbers, as we'll be reviewing. And imaginary numbers are used in the real world. Engineers actually use them to describe electrical currents. One of my really good friends is a really talented designer. We are working together on a lesson for you guys on exactly how he uses design and puts it together with a lot of math concepts, particularly complex numbers. So with that being said, let's do a quick review. Before we even move into what a complex number is, there is an imaginary unit, which is I. So first of all, I squared is -1, and therefore, if you square root that I, the square root of I is the square root of -1. The square root of -1 is imaginary, right? It can't be an actually real number, and so that's why it has its own unit separate from a real one. Now we know what I stands for, at least we remember. So then let's move into what a complex number is, which is any number that can be written as a plus bi, where I is the imaginary unit and a and b are numbers. So for example, it would be 5 plus 7i, 7 minus 12i. 0 plus 5i. Those are all complex numbers that combine a real number with some imaginary units, right? So then moving into plotting points on a complex plane. So this looks a lot like your Cartesian plane, right? You have your x and y axis, or your x and y axis, and then you have all the numbers and all the intervals, right? So we can use the complex plane to visualize exactly how complex numbers work. So notice that they intersect at a right angle, just like your regular plane at 0, 0 at the origin. Your x-axis is your real axis, where your real numbers live. And your y-axis is your imaginary axis. So think y is I. Y-axis is imaginary numbers I. So when you plot these points, you're plotting your real points on your real axis and your imaginary points on your imaginary axis. We are going to use the help of my good friend Sal Khan of Khan Academy.
Move the orange dot to -2 plus 2i. So we have a complex number here. It has a real part, -2, has an imaginary part. You have 2 times I. And what you see here is we're going to plot it on this kind of two-dimensional grid, but it's not our traditional coordinate axes. In our traditional coordinate axis, you're plotting a real x value versus a real y coordinate. Here, on the horizontal axis, that's going to be the real part of our complex number, and our vertical axis is going to be the imaginary part. So in this example, this complex number, our real part is the -2, and then our imaginary part is a +2. And so that right over there in the complex plane is the point -2 plus 2i. Let's do a few more of these. So 5 plus 2i, once again, real part is 5, imaginary part is 2, and we're done. Let's do 2 more of these. 1 plus 5i. 1, that's the real part, plus 5i, right over that im. All right, let's do 1 more of these. 4 minus 4i. Real part is 4. Imaginary part is -4. Is -4. And we're done.
That is exactly how you are solving the problems on the first section of your Delta Math. Now, the second portion of your Delta Math is finding the modulus of a certain point on the complex plane. Before we move on, let's talk about what the modulus is. The modulus, in other words, the absolute value of a complex number, a plus bi, is the distance of the plotted value from the origin. So if you remember, absolute value is the distance of a number from 0, right? And distance can never be negative. And that's why we look at number lines, right, and how absolute value is distance from a zero. Modulus is the same thing, but for a complex number. So we're trying to figure out how far that point is from the origin or from zero, right? Similar idea. So let's do one example together. So you try to find the absolute value or the modulus of 2 plus 5i. So the first thing you are going to do is you are going to plot your point. So pause this video right here and point to where you would plot that point. All right, so if you did it correctly, then you would move it over to the right on the real axis. You move it to the right 2 because that's our x-axis, and then y is I. So our y-axis is our imaginary number. So you're also going to move up because it's a positive 5. You are going to move up 5 units. So first you plot your point. Then once you do that, you want to think about, okay, so modulus is the distance a plus bi from the origin. So how can I figure out the distance from the origin? The way that you do that is that you want to visualize a triangle. Yes, triangles are back. You thought they were gone. They never leave. So you are going to draw a triangle similar to how we do our unit circle triangles. You are going to bring down that triangle to the x-axis, and then you are going to complete it this way. When you create your triangle, then you know this is a right triangle. Let me draw a little thing that'll tell you that's a right triangle. So now you know 2 of your 3 side lengths. You know that you move 2 to the right to get the x, the horizontal length, and you moved 5 units up to get your vertical length. Wow, that's really hard with a trackpad. So you have those 2 values. Now you want to figure out what is the distance between the origin and this point. So let's get a nicer drawing of that than mine. So what do you think we are going to use? Drum roll, please. What do we need? Yes, we are using Pythagorean theorem. So you already have 2 legs. You have A and B. So you're going to plug in the lengths that you already know, 2 and 5, into your Pythagorean theorem. So 2 squared plus 5 squared equals c squared. And then you're going to get the square root of that. So that'll give you 4. 5 squared will be 25. You add up those 2 numbers and you get the square root of 29. So your answer then is just the square root of 29. That is how far your origin is from that plotted point. That's it. So we're going to do a quick check for understanding. So the first person, upon watching this video, to text me the correct letter choice of this CFU gets a special surprise. I'm really excited about it. So without further ado, your question is, what formula do you use out of these 4 to find the modulus? A, the midpoint formula, B, the Pythagorean formula, C, angle sum formula, and D, complex number formula. Go ahead and text me the letter choice for a special surprise. Last but not least, I'm going to give you the opportunity to try one on your own. So go ahead and write down the exact value of this modulus of 5 minus 8i. So remember, the first thing you have to do is plot that point. Go ahead and pause this video, try it out on your own, and then on the next slide, I will show you what the answer is. All right, so you should have gotten that C, or that modulus, is the square root of 89. If you did, awesome. If you did not, then here is a hint. 5 minus 8i would be graphed just like this. So think about, what formula do you need to use to find that actual length and go from there. I hope you guys are doing well. That's all I have for you today. Take care of yourself, Curbs, and until next time.